Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So, today we are going to talk about the exponential function and logarithm function on the special focus on the application of the exponential and logarithm function. Let's start. Now, the first application is the optimization. Find the local minimum of fx, that is x squared minus 8 ln x. Okay, don't forget the domain of function, because it involves natural logarithm, it must be from 0 to infinity. Okay, the local extrema can occur at, how do I find the local extrema? First, the stationary point, f double prime equals 0. So f prime is given by this. I can look at this, and I can simplify this as this. Okay, yeah. So what is the stationary point? We just look at the numerator, that is x equals 2 and x equals minus 2. So x equals 2 and x minus 2 is the stationary point. Okay, yeah. Okay, but it can changes at x equals 0. Yeah, but x equals 0, no, because the domain is 0 to infinity. Oh, I'm sorry, minus 2 is not included. Okay, yeah, because the domain is from 0 to infinity. Okay, now how do I find the okay, yeah. So I can look at this is plus minus plus 0 to the left. But 0 to the left we can just left out because it is not in the domain of our function f. Okay, now we have decrease and increase. Don't forget 0 is not included there, because it is not on the domain. So decrease, increase, so 2 should be the local minimum. Okay, yeah. So there is a local minimum at x equals 2, and the minimum value you can just plug in x equals 2 to the here to the function. Okay, yeah? Careful on where to substitute the x equals 2. Okay, x equals 2 you substitute not to f prime but to the f. Okay. The second one, graph the exponent function e to the minus x squared. Let's look. The same, the domain first. The range, don't forget this is an exponential function. It should be positive. Sorry, it cannot be 0. So 0 should be left out. Yeah, 0 it should be not included. The y-intercept x equals 0, e to the 0 is 1. So the y-intercept is 0, 1. How about the monotonicity? F prime x is this. Don't forget, e to the minus x squared cannot be 0. So what can be 0? This just 1. So the 0 is given by x equals 0. Okay, yeah? So this is the monotonicity. I can look this 0, it changes sign as 0. You can check, just plug into this, you have minus plus. So increase, decrease. So you have a local maximum here at x equals 0. Okay, yeah? It has a maximum at local maximum, I mean. Okay, what about the global, this, yeah? Global. Okay, for all real. For what about the concavity? I can try find one, and in the end I have the zeros is this. I can look at the sign diagram, minus plus minus, so concave downward, concave upward, concave downward. Okay, yeah, and it has two inflection points, that is minus square root of 2 and square root of 2. Okay, yeah, and I can combine all of this information to find this one. Okay, plus or minus, it should be this, it should be this, sorry, this, it should be this, it should be this, and you can combine this like this. Asymptote, asymptote. There are no vertical asymptote, but the horizontal asymptote, because this is e to the power of something, is y equals 0. Okay, yeah. Combining the concavity and monotonicity, this, and the graph is given by this, with a global absolute maximum is 1. You can look at other application in your textbooks, and be sure you have to have lots of exercise on this. Okay, thank you very much. This is the end of our lecture on the exponential function and logarithm.